Ever wondered what the differences between RIPv1 and RIPv2 are? Well, let's embark on a journey to explore the intriguing landscape of dynamic routing protocols. You're about to discover the intricacies and nuances behind these two versions of the routing information protocol. With a world that's becoming increasingly interconnected, understanding these protocols is more essential than ever. So buckle up and get ready. Today, we're going to delve into the fascinating world of dynamic routing protocols, particularly RIPv1 and RIPv2. To start with, let's explore RIPv1. RIPv1, or Routing Information Protocol version 1, is a dynamic routing protocol. It's a part of the distance vector family of protocols that routers use to exchange network topology information. It's a standard protocol, meaning it can be used on routers from different vendors, making it a versatile tool in network engineering. One of the key features of RIPv1 is its simplicity. It's relatively easy to configure compared to other routing protocols. However, it's worth noting that because it's an older protocol, it has a maximum hop count of 15, which can limit its use in larger networks. Now, let's dive into the configuration process. The first step is to enable the RIP protocol on the router. This is done by entering the global configuration mode, then typing router RIP. Next, you specify the networks that the router will advertise. You do this by typing network, followed by the network address. It's important to remember that RIPv1 works with classful addressing, so it doesn't support variable length subnet masks or VLSMs. To verify your configuration, you can use the show IP route command. This will display the router's routing table, where you should see the networks you specified earlier. In terms of use cases, RIPv1 is often used in smaller, simpler networks due to its easy configuration and classful nature. It's also commonly used in educational settings, as it provides an excellent introduction to dynamic routing protocols. However, it's essential to remember that while RIPv1 has its merits, it has been largely superseded by more advanced protocols, including its successor, RIPv2. These newer protocols offer more features and better scalability, making them more suitable for modern, complex networks. That was a brief overview of RIPv1. Now let's shift our focus to RIPv2. RIPv2, an enhancement of RIPv1, has some interesting features to offer. So, let's delve into the world of Routing Information Protocol version 2, or simply RIPv2. Born out of a need for improvement, RIPv2 was designed to address the limitations of its predecessor. Imagine RIPv2 as the upgraded version of your favorite gadget. It's got all the features you loved in the previous model, plus a few extra tricks that make it stand out. RIPv2, just like RIPv1, is a distance vector routing protocol, but it brings to the table a couple of key enhancements. Firstly, it supports variable length subnet masks, or VLSM, which allows for more efficient use of IP addresses. Secondly, it uses multicast addressing rather than broadcast, reducing the load on network resources. But wait, there's more. RIPv2 also supports authentication, a security feature absent in RIPv1. This means that routers can confirm the identity of the source before accepting routing updates, thereby increasing network security. So how does RIPv2 work? Well, the configuration and verification process is quite similar to RIPv1 with a few added steps. To configure RIPv2, we first enable RIP on the router. Then we specify the version as 2, and finally, we add the networks we want to advertise. To verify that RIPv2 is functioning as expected, we can use several commands such as show IP route or show IP protocols. Now, let's talk about use cases. RIPv2 is ideal for small to medium-sized networks where simplicity and ease of configuration are key. It's also a good fit for networks with VLSM and those requiring a basic level of routing protocol security. In essence, RIPv2 takes what was good about RIPv1, its simplicity and robustness, and builds upon it, adding flexibility, efficiency, and security to the mix. Now that we've covered both RIPv1 and RIPv2 individually, it's time to compare them head to head. And that, my friends, is a conversation for our next scene. As we dive into the comparison, you'll find that RIPv1 and RIPv2, while similar, have significant differences. Let's kick off the comparison with the basic understanding of these two routing information protocols. RIPv1, or Routing Information Protocol version 1, is a distance vector protocol that uses hop count as its metric. On the flip side, RIPv2, also a distance vector protocol, has the added advantage of using subnet masks, which allows for variable length subnet masking, or VLSM. Diving into the nitty-gritty, RIPv1 is a classful protocol. This means it doesn't support CIDR or classless interdomain routing, and it doesn't send subnet mask information in its routing updates. In contrast, RIPv2 is a classless protocol. It supports CIDR and sends subnet mask information in its routing updates. This is a substantial advantage of RIPv2 over RIPv1, making it more flexible and efficient in handling complex networks. Let's talk about security. RIPv1 doesn't support authentication, so it's vulnerable to unauthorized access and changes. However, RIPv2 has stepped up the game by supporting simple password and MD5 authentication, thereby providing a layer of security to your network. Next, we move on to the protocol type. RIPv1 uses broadcast to send updates, which can cause unnecessary traffic on your network. RIPv2, however, uses multicast, sending updates only to devices that need them. This is a more efficient method, reducing network congestion. Now let's consider the routing update method. In RIPv1, full routing updates are sent at regular intervals, regardless of whether there's a change in the network. This can lead to excessive bandwidth usage. On the other hand, RIPv2 supports triggered updates, which means updates are sent only when there's a change in the network, thus saving bandwidth. When it comes to the compatibility factor, RIPv1 and RIPv2 are backwards compatible. RIPv2, with its additional features, can operate in a network with RIPv1 routers. However, to leverage the enhanced features of RIPv2, all routers need to be RIPv2. So, when should we use RIPv1 and when to use RIPv2? Well, if you have a small network with no subnetting, RIPv1 could be a simple and effective solution. But for larger, more complex networks with subnetting, RIPv2, with its support for VLSM, authentication, and triggered updates, is undoubtedly the better choice. With these comparisons, you should now have a clearer understanding of when to use RIPv1 and when to use RIPv2. So, we've had quite a journey exploring RIPv1 and RIPv2, haven't we? We began our adventure with RIPv1, delving into its structure and operation. We discussed how it's a distance vector protocol, using hop count as a metric to determine the best path for data packets. We also highlighted its limitations, particularly its lack of support for variable length subnet masks, VLSMs, and classless interdomain routing, CIDR. This led us to the introduction of RIPv2, a significant improvement over its predecessor. We examined how RIPv2 addresses some of the shortcomings of RIPv1. With its support for VLSMs and CIDR, we saw that it provides a more efficient and flexible routing solution. We also discussed its use of multicast addresses for updates, which reduces network traffic compared to RIPv1's broadcast method. But our exploration didn't stop there. We then moved on to comparing these two dynamic routing protocols. One of the key distinctions we made was their approach to routing updates. While RIPv1 uses broadcast, RIPv2 uses multicast, leading to more efficient network resource utilization. Another significant difference lies in their subnet handling. With RIPv1's lack of support for VLSMs and CIDR, it can lead to inefficient use of IP addresses. On the contrary, RIPv2's support for these features allows for better IP address management and network design. We also touched upon the use cases of these protocols. Despite its limitations, RIPv1 is still useful in small, simple networks where subnetting is not required. However, for more complex networks, especially those requiring subnetting, RIPv2 is the preferred choice. In short, both RIPv1 and RIPv2 have their unique strengths and use cases. RIPv1, with its simplicity, is suitable for small networks. In contrast, RIPv2, with its enhanced features and flexibility, is more apt for complex network environments. I hope this episode has provided you with a better understanding of these dynamic routing protocols. Remember, the key to mastering these concepts lies in continuous practice and exploration. So don't hesitate to experiment with these protocols in your network simulations. That's it for today's episode on dynamic routing protocols. Keep exploring, keep learning, and see you in our next episode next